Hello, this is Chapter 5 in the GCSE topic of space, and today I'll be covering the idea of redshifts. When I first heard the word redshift, I had no clue what it meant, but after I spent a little time learning about it, I have to admit that it's a fairly simple concept. Now, I'm not going to start off like I usually do by explaining what the concept means straight away and explaining what it means afterwards. I'm going to tell you about wavelengths first. Wavelengths are the distance between two crests on a wave. You can clearly see the wavelengths on the waves in this image. It's the distance between the two tops of the wave, known as the crests. We can also clearly see that we perceive the different types of wavelengths as colours. For example, the wave with the highest wavelength of around 700 nanometers is red. Maybe this is something to do with redshifts. Well, yes, it does, because redshifts are the shifting of wavelengths from distant galaxies to the end of the spectrum, being red. For example, a normal wavelength may be green, but over time it has shifted to red as the wavelength has increased. But why is this happening? This is because of the Doppler effect, which states that the closer a source is to you, the more the wavelengths will decrease, and the more the frequency, which is the rate of the waves, will increase. And of course, this also means that the further away you get, the more the wavelengths will increase and the more the frequency will decrease. Now, this is a fairly simple idea as long as we compare it to the picture of a fire engine. When we are further away, the pitch is lower because the wavelengths are long and you can't have as many ups and downs in the wave. But when it gets closer, the pitch increases as you get more short waves. This led to a theory being made that the universe is actually expanding. When we observe the wavelengths of distant galaxies, we find that the wavelengths have increased, called a redshift, and because of the Doppler effect, this means that the galaxies must be getting further away. And we've also found that the furthest away galaxies are getting even further away the quickest. If we imagine a balloon with pom-poms on, representing the galaxies, when we make the balloon bigger, we notice that the pom-poms have become more spread out, and this is what is happening with our universe. But we also notice that if we imagine being in the centre of the balloon, we would see the closer galaxies only move a tiny bit, and the galaxies, or the pom-poms, on the edge of the balloon moving much more. And that's why we perceive the most distant galaxies moving the furthest. And so there you have it. That was the redshift. In my next video though, I'll be discussing how the redshift can prove the Big Bang theory of how the universe was created. I hope you found this video interesting and useful, and I'll see you in the next one.